Okay, so when we consider about the lab guide, the MPLS VPN, it is not I didn't design it to difficulty. So you can find that it is just a simple topologies, and we don't have so many difficulty requirement to meet. So I think this experiment just let the student to know what is MPLS VPN. And maybe we will examine some things about MPLS VPN, but I'm not sure. But one thing I can show is MPLS VPN will not be the most important part of the lab exam. Okay, now let's look at what the experiment about MPLS VPN. You will find that it is just intra-domain MS VPN, so we don't have the experiment about the inter-domain MPLS VPN. Now, first, let's look about the objective about this experiment. It shows that in the MPLS VPN experiment, we must consider about the LDP, and then it is MPLS VPN. And it shows that we will design the CE and PE's interworking IGP protocols, or you can use the BGP. It should be the eBGP protocol to switch routers between P and CEs. So you will find that in this experiment, we design different IGP and protocol. You can see that you find that in this part it is OSPF, and in between this part it is eBGP, and also in this part it is also a eBGP protocol. Okay, we will use different way to exchange router between C and PEs. And then the most difficulty part in this experiment, it is the RT values. We design RT values, and we have two IP VPN instances in this device. This device is function as a P device, although its name is P2. But you can find that its function is a P device, and it is HQ's PE device. So we designed two IP VPN instances in this device. One VPN instance is used to receive router, and this router will send from P2 to P1. And then we design another IP VPN instance. This VPN instance is used to send the router to other branches. For example, branch 1, the router from branch 1. It is sent the router PE2 will send the router VPN v4 router to P2, and P2 receives the router will send it to P1, and P1 will send the router back to P2, but use another VPN instance. Then P2 will send the router to another branch. So we design this just to let all the traffic between different branches. The traffic will pass through the HQ's device, will pass through the HQ's C device. That is I think the most important part about this experiment, just to design different traffic paths. Now let's look at the introduction to the experiment. And I think you find that it is not a difficulty topology, just to have 3 devices to function as the backbone, MPLS backbone, and 3 devices to function as the CE device. And we have, and all the devices and all the IP addresses between the routers have already been mapped in the topologies, and the subnet have already been shown in this. And all the router we will create an interface, and the interface should be look back 0, and the IP address should be 10.0.x.x, and the value of the x will be shown in the corresponding step. And so we have already introduced in this experiment. Our first aim is to control the route between the branch. Right. Okay, now let's look at the configuration route map or the step of the experiment. What we will do. First, it is the basic configurations about the device, and then we need to configure the IGP protocols. We'll use the SIS to function as the underlay protocol of the backbone, and then we will configure MPLS. It should be enable MPLS function enably, and we need to enable MPLS function and MPLS LDP function inside the interface wheel, and also we should configure the MPLS LSID. Also, we use the loopback ZL IP address to function as the MPLS LSID. And then when we finish the basic MPLS configuration, we need to configure the MPLS VPN. We need to create a VPN instance on the on the P device. I mean, the device function as PE, although maybe its name is P or its name is PE, but you should notice that it's just the device name. And we will create a VPN instance on all the devices that function as PE. And we need to configure the RT value as we designed, so we can control the route between the branches. And you will find that the last three steps is about the VPN instance and the interworking protocol between the P and CEs. So let's look at what we will do in our experiment. The first one is the basic device configurations. Is about the IP address, about the device name. And I have already said the value of the X and all what is the IP address of loopback 0. We will show in the corresponding table. You will find that. And then it is the basic configurations to configure the IP address of the interface loopback 0, configure the IP address of the interconnection interface, and then we will configure the SIS to function as the IGP, the only IGP protocol. And we will configure the NIT ID to this value, and you should find that it is also has X values, and these X values I have already shown in this table. So it is not so difficult. It is just to enable the SIS and enable SIS on the corresponding interface. It is not too difficult. You can find that after we finish its configurations, maybe we need to check the SS router, the SSPR is right. And then it is the MPLS configurations. It's not so hard. First, we need to configure 3 commands on every device. The MPLS LSID, enable MPLS function, enable MPLS LDP function on every device. Actually, we only have 3 devices to function as backbone. And then we need to enable MPLS and MPLS LDP function in the interconnection interface. And then we need to check if the MPLS LDP adjacency relationship is established normally. So you can find that after we finish the basic MPLS configurations, all the LDP neighbor have already been established. And then it is configurations about the level 3 VPN configurations. We shall know that all the MPLS VPN, if we need to use the MPLS VPN, the first things we need to deliver the VPN v4 router between PEs, and maybe we will use one device to function as a router reflector. But the first thing is how to deliver VPN-v4 routers. Will need a new address families about the BGP. It is the IPv4 family, VPN-v4. So the first thing is we need to establish MP-BGP peer relationship between PE. And you will find that in this experiment, we use the P2, this device, to function as RR. So in the P2 device, P2 only needed to establish the BGP peer relationship with the R device, and then we need to enable the peer relationship inside the VPN-v4 address family. And but for the P2, it is the R device, so it needed to configure all the P device to function as the RS client. And you can notice that, and all the R need to disable this command policy VPN target, just because for the R device, it needed to reflect the router that received from its client. If it check the RT values, it don't have the ability to reflect the router to other PEs. So we need to use this command undo policy VPN target to disable the RT values check. And then we need to check if the VPN-v4 peer relationship is established normally. We can use this command. Now we have already finished our control plans configuration, and then the things we need to do is we need to generate the router that from the CE and swap or delivery the router from the CE to PEs, and then PE will generate the routers that learned from CE to a VPN-v4 router, and then send it to its VPN-v4 peers. So let's look at what we will do in the experiment. The first thing is we need to finish the configuration between the HQs, CE, and PEs. The first thing is we have already introduced that we will use two VPN instances in the HQs PE. One VPN instance is used to receive router, and another one is used to send routers. And our aim is that all the router learned from the PEs branches PEs will be its next hop should be the RRs, and in the RR, its next hop should be the HQCEs, so that all the traffic communication, the communication traffic between branches, they will pass through the HQCE. So how to achieve this? We will find that in this experiment, in this topology, between the HQs P and CE, we only have one physical link. So, but we needed to use the two VPN instances. How to do that? So we needed to create another logical interface. So you will find that the first thing we need to do is configure a sub interface between P1 and P2. It is the HQs CE and PE, and we need to configure the sub interface a same terminal with an ID, and we need to configure its interconnection interface IP address, and then we need in the P device we need to configure its BGP peer relationship. You will find that it is this and this device is the HQs CE, and then we need to configure the VPN instance, and its name is VPN engine and VPN out. And I think if you see its name, you should know that its function. And then we will have a table. In this table, we showed that how to configure the VPN instance, its name and the RT values, and the RT value include the import RT value and export RT values. You will find that for the VPN instance, VPN engine, it only have the import RT value, and it has two values. One value is used to receive route that sent from the PE2, and another value is used to receive route that sent from the PE4. And for the VPN instance, VPN A out, it only have one export RT value, right? And this value is configured on the PE2 and PE4's VPN instance. So by the value we designed, we can control the route sent and received. Okay, now let's look at how to configure the RT value. I think you must be very familiar with it. So you will find that it's just a normal MPLS VPN instance configuration. You just we need to design its value, and then we need to bind the VPN instance into the interface, and then reconfigure the IP address. And then in the HQ's PE, we needed to establish the BGP peer relationship inside a new address families, or inside the VPN instance. You will find that we need to configure the BGP peer relationship inside this address family, AP with family VPN instance. And you will find that for the peer relationship, we need to follow another additional parameter, right? This parameter and this parameters. And the first parameter is the substituted AS. It means it's just because if you check the route that received from by the inside the VPN engine, you find that the PE, it will discard the route just because inside the route as P1 will find itself as number, so it will discard the routes. So how to do that? Just in this device P2, it will just change the as value so that P1 will not discard these routers. And actually, in the P2, in the VPN instance, VPN out, it will have the same things, but we use another command to let this VPN instance will receive the router. This command is AS loop. You should know that it will allow the AS path, the AS value in this path to to the deprecated for once by default, but you can use this value to set the value that as number that just shown in the S path. So after by use these parameters, the P2 and the P2 can send the route that learned from the branches to the P1. The P1 is the HQ's CE, and CE will receive the route normally. And then by use this parameter, the P2's VPN instance, it will receive the route that sent from the P1 normally. After we finish this configuration, we need to check if the BGP peer relationship is normally on the P1 and P2. And then the next thing we need to do is we need to use one interface to function as or to simulate the terminal or the service. So we need to create an interface lookback one and configure its IP address. and then we need to network, or we need to advertise, or we need to import the router into the BGP. And then we need to configure the CE and PE's connection on branch 2. You will find that on branch 2, we will also use the BGP protocol to function as the protocol to change routers. And we need to configure the IP VPN instance on PE4. And we need to bind the VPN instance to the interface. And then we need to establish the BGP peer relationship inside the VPN instance. And also we need to use this parameter substituted AS to just change the AS number that carried in the router. And this device PE3, it is function as the branch 2 CE. And we need to configure the BGP peer relationship. And then the things we need to do is we need to create the interface, and we use this interface to function as the terminal, and then we need to network this router into BGP. And then the next part about this configuration is we need to configure the CE and PE's interworking IGP protocols on branch 1, and you will find that we use the OSPF to function the IGP protocols. And then the first thing is we need to configure the VPN instance as we designed, and then we need to bind the VPN instance with the interface and reconfigure the IP address. And then the things is we need to configure the OSPF on PE2. It is the PE device of the branch 1. And you should know that we need to configure the OSPF process followed by the VPN instance parameters. And then inside the OSPF process, we need to import router from BGP, and we need to set its default cost and its default route type to type 2. And then we need to enable the OSPF process in the interconnection interface. And for this device, it is PE1. PE1 is function as the branch 1's CE. And then we need to enable the OSPF process on the corresponding interface. And then at last, on the PE1 on the C device, PE1 its function as the C device of branch 1, create the loopback loopback 1 interface, and configure its IP address and enable OSPF process on this interface. And then you will find that we have already established OSPF peer between the CE and PE of the branch 1. And then you will find that the last step that we need to do is we need to import OSPF router to BGP into BGP. All right, but we need to do a limitation just because we only want this router about this interface to import to BGP. So we can use So we can use this function, the IP prefix list and router policy, this function to match the specific router, and then inside the BGP view, when we import a router from OSPF, we can use the router policy to limitate the router. Okay, last step is router verification. We need to check if the router's next hop is followed our design. First is we need to check the VPN-v4 routing table of the HQ's PE. It is P2, and we use this command display BGP VPN-v4 VPN instance VPN in routing table, and you can find that we have these routers 10.1.1.1.1 and its mask is the 32, and this one, they are all learned from the branch, right? And then you need to check the route on P2. You should know that P2 it is the HQ's CE, and you need to check routing table on VPN alt. Oh no, P2 it is the HQ's PE. You will find that the VPN alt, all the router that learned from the branch is next hop is not the real next hop. The next hop is the HQ's CE 10.0.0.13, right? The next hop is P1. It is the HQ's CE. It means that router inside VPN alt. It means that the router will be delivered to the PE. Another PE is another bridge, and so for other branches, all the routers that learned from the HQ's PE, the next hop will be this, but it should be changed. Now let's look at let's check the BGP VPN-v4 routing table on PE2 and PE4. PE2 and PE4, it is the branches PE. First, let's look at the PE2. You will find that for PE2, all the survey routers to other branches and the headquarters, the next hop is the PE's headquarters, just because the router is learned from the HQ's VPN instance VPN alt. And for the PE4, the result will be the same. And let's check the IGP routing table of the PE1 and PE3. You will find that for PE1, the OSP routing table have already learned the router that from the HQ and another branch. It should be this one, and this one you should have already found that. And for the PE3, you can check the BGP routing tables. You will find that it have already learned from the HQ and another branches, and its next hop is this. And this next hop is the PE. It's it itself PE. And then if we try to trace route the traffic path, you will find that from one branch to another branch, you will find that we will pass through so many hops, and you will find that for this hop and this hop, for these hops, you will find that for these hops, it is IP address between HQC and PS. So by the RT values, by the RT value, by design the RT values, we achieved our requirement. We let the traffic between the branches all forward pass through HQ's CE. So if you want to do some operations, for example, if you want to like all the traffic between branches to pass through a firewall, you can do it just because now the traffic have already reached the HQ's CE. You can do other things. For example, you can use the PBR or other functions to let the traffic pass through the firewall or other security check device. And actually, I think it is a normal function, a normal design in the real network. Okay, that is all the content about the MPLS VPN. And MPLS VPN, you will find that it's not a hard experiment, just because now for our lessons for the HCIE.com. It is not the most difficulty part of these lessons. Maybe you should put more attention to what is VXLAN, what is Huawei's solutions about campus network, about the BRI one network, about the interconnection between the branches. Maybe you should pay more attention about Huawei solutions. Okay, any questions about this part?
I've got one question. Can you tell me a little more about the substitute AS command? Because frankly, I saw this command for the first time, and I wish to know a little bit more about this command.
A moment, which command about the experiment?
In BGP, there was this substitute AS.
Oh, yes. And wait a moment, you have some confused about, wait a moment.
Yeah, it was the red one. You marked this as a red. Oh, here.
This substitute. Yes. You should know that if we have a AS number in the AS path, and if the AS number is the same as the device itself, so we will not receive the root, right? For example, you will find that in this topology, the AS number in HQ and the AS number in the branch 2, they are the same, right? So the VPN router that generated by the PE4 to the P2, it will receive the router just because for P2, its AS path, its AS number is this, is not same as the PE4, right? But if P2 set the router to P1, P1 will not receive the router just because the router carried the same AS number with itself, right? So if we use this command, P2 will change the AS number to itself.
Okay, so it's not like fake AS. It's just make the just swap the 65003 to 65100.
Yes, it is.
Okay.
Yes, it is right. I think you have already understand it. Okay.
Okay. Thank you.
Okay.